Okay, we are going to take a look at an example that asks us to find the distance between 2 points and the midpoint of the line segment connecting those 2 points. So before we take a look at a specific example, let's just review a couple of results that we can use. So I've got a point P, which has coordinates x0, y0, and a second point Q, whose coordinates are x1, y1. And the distance between them, D, is going to be the length of that line segment in black right here. And from these 2 points, we can create a right triangle. So here's one side of that triangle in red, and here's the other side in blue. And the coordinates of this point over here would be x1, y0, since we have the same x coordinate as the point Q and the same y coordinate as the point P. And so now we can use the Pythagorean theorem, where we have the length of the bottom side here, which is x1 minus x0. That would be the distance from here to here. And we don't need to worry at the moment whether these things are positive or negative, whether these differences are positive or negative, because we're going to square them in a second. And so the length of the blue line segment is equal to y1 minus y0, or perhaps the absolute value of that difference. And so now Pythagorean theorem says that if we have a right triangle, a squared plus b squared equals c squared, where now a, this denotes the distance x1 minus x0, so x1 minus x0 squared plus b squared, which is y1 minus y0 squared, equals the hypotenuse squared. And that hypotenuse has length equal to the distance between these 2 points. So solving for d, we get the square root of x1 minus x0 squared plus y1 minus y0 squared. Square root of all of that. So here's where the formula for the distance between 2 points come from. It's just a result of the Pythagorean theorem. And it's worth mentioning at this point that here we wrote this formula using x1 minus x0, y1 minus y0. We could have reversed these differences, for example, and done x0 minus x1, y0 minus y1, because we're squaring these things. So changing the order would change the sign, and then we square it so that we would get the same answer either way. Next, let's take a look at the midpoint, how we can find the midpoint between these 2 points. So the midpoint M I've written on the line segment connecting P to Q. And so to find the coordinates for the midpoint between P and Q, we go halfway up and halfway over along the line segment connecting these 2 points. So we go halfway over, and that would put us at an x-coordinate, which is equal to x0 plus x1 divided by 2. That's going to be the midpoint between those two. And then we go halfway up between these two, and for that, we do something similar. We find the midpoint between y1 and y0, which is y0 plus y1 all divided by 2. And that gives us the coordinates for the midpoint M between these 2 points. And now let's take a look at how we can apply these distance and midpoint formulas to working with the points P and Q, where P is at 2 minus 5. So we'll call this our x0, y0. And Q is at 6 minus 2. So that's going to be our x1, y1. And so the distance, D, we get by taking the square root of x1, which is 6, minus x0, which is 2, squaring that, and then adding the difference of y1, which is minus 2, minus y0, which is minus 5, squaring that. So, doing the arithmetic here, we get the square root. 6 minus 2 is 4 squared. And when we take minus 2 and subtract minus 5, in other words, when we take minus 2 plus 5, we get 3 squared. And this gives us the square root of 16 plus 9 is 25, and the square root of 25 is 5. So that tells us the distance between the 2 points is 5. To find the midpoint between these 2 points, remember we're going to go halfway between the x coordinates. So we're going to take x0 plus x1, divide by 2. That's going to tell me the x coordinate, and we're going to go halfway between the y coordinates. y0 plus y1 divided by 2. So here we have that x0 is 2 plus x1, which is 6, and divide that by 2. y0 is minus 5 plus y1 is minus 2, and we divide all of that by 2. So simplifying this, we get that m is equal to 6 plus 2 is 8 over 2, minus 5 plus minus 2 gives me minus 7 over 2. So this tells us that the coordinates for the midpoint are 4 minus 3.5. Okay, and the 4 again is halfway between 2 and 6, the x coordinates, and the minus 3.5 is halfway between the minus 5 and the minus 2, the y coordinates.